Hello everyone, this is Mr. Geiselhart, and this lesson is going to be on rotations around a point, and we're only going to be concerned with certain degrees of rotation: 90, 180, 270, and 360. The first thing we have to ask ourselves about rotation is which direction are we moving? Are we moving clockwise or counterclockwise? Clockwise just means we're moving the same direction as a clock normally moves when you're rotating around, while counterclockwise means we move the opposite direction of a normal clock. So these two things show clockwise motion and counterclockwise. So if I just did that using an arrow, I could draw something like this, that clockwise motion would be going in this direction, and counterclockwise motion would be going in this direction. In this case here, the center of rotation is going to be the origin, which is the point 0, 0. So we have that set up right there. Now what I'm going to do is I'm going to have this rotate around the origin a few times, and we're going to do it kind of fast to start. So what you can see is that this triangle that we have moving around here is just going around in a circle when we do that. When we talk about rotation of 90, 180, 270, or 360, what we're talking about is rotating it. Here would be 90 degrees. Down here is 180 degrees. Over here is 270 degrees. And then back up here would be 360 degrees. Now, this direction here is a clockwise motion. If I go this way, that is a counterclockwise motion around the origin. All of the rotations that we'll be doing will be around the origin. If we look at this given triangle, notice that the original triangle is in quadrant 2. We also want to look at a specific point. In this point, we're going to be looking at A. And I know it's a little small here, a little hard to see, but this is point A up here, and the coordinates are -5, 7. So the first thing we're going to do is see what happens when we rotate that 90 degrees clockwise around the origin. In this slide, you can see that the original triangle has been rotated 90 degrees around the origin. So let's find the coordinates of A prime. Now, A prime is the same thing as saying the coordinates of A after it has been rotated. The prime is this little apostrophe. We read that as prime, and that's the apostrophe. Again, it's a little small here and hard to see, but it says A prime here, and then it gives the coordinates of my new point, which is 7, 5. So let's take a look at what the original coordinates were. So if I look at the original coordinates for A, that was at -5, 7. And then if I look at A prime, that's going to be at 7, 5. Now, we can look at those two numbers and try and see what happens. If I look at my original point A and said that that was just at the coordinates x, y, and then I want to look at A prime, what did I do with this x and y? Well, you'll notice that the y from the original just became the x in the new one, and the x in the original, we had to make it negative, or we had to change the sign and make that the y in the next one. So now let's just take a quick look and see if that works for the other points. So let's take a look at the point C. Point C right here is at -3, 2. Well, point C here is at 2, so C prime is at 2, 3. So I just took y and put it in for x. I changed the sign of x and put that in for y. Here we rotated the triangle 180 degrees around the origin. Now let's look at what happens to the coordinates there. So if we start with A is at the point -5, 7. Then let's find A prime. A prime is right down here, and that's at the point 5, -7. So if I do the same thing we just did with x and y, let's see what we did with our x's and see what we did with our y's to get the new point. To get the new x, I just did the opposite of the original x, and to get the new y, I did the opposite of the original y. So when you rotate it 180 degrees clockwise, then you'll end up with -x, -y. Now, I just used the word clockwise, but notice it doesn't say clockwise up here. Well, as it turns out, when you do 180 degrees, it doesn't matter if you go clockwise or counterclockwise because it's exactly halfway. So whichever direction you went to get there, you're still going to end up in the same spot. So this one we're going to take a look at when we rotate it 270 degrees clockwise around the origin. So if we start here, we go 270 degrees over here. So now we're down to quadrant 3. Let's take a look at the points again. So if we start with A, that's at -5, 7. Now let's look at A prime. For A prime, we have -7, -5. So again, let's take a look in terms of x and y and see what happened to the original coordinate. So if we start with just xy, here I took x and that becomes my new y. It didn't change, so that's just going to be x. I had to make my y negative and put that in place of x. So that's going to be -yx. And again, we can check that with another point. Let's look at the point B. B starts out being at -5, 2. So B prime should be at, well, my x becomes my y, so that's -5. I have to do a -y, and that becomes my x, so -2, 5. So if I come down here, that's exactly where it's at, is -2, -5. Okay, and here's what we're going to do to summarize the clockwise rotation. I have it listed out there. I'm not going to just read it to you. You can take a look at that if you want. You can pause the video and copy that down. But for main thing I want to talk about is, does it matter which quadrant we start in? And the answer is no. Let's take a look at quadrant 1. If I start with my A prime, and that's going to be at the point 7, 5, in order to find A double prime, which is the second one that we reflected or rotated, I'm going to take my x, make it negative, and it becomes y. I take my y, and that's going to become x. So it should be at the point 5, -7. And if you come down here, that's the point 5, -7. So these work no matter where you start from. It doesn't matter which quadrant you start from. These transformations will work every time. Let's go back to our original shape in quadrant 2 again, the original triangle. This time we're going to be doing rotating it counterclockwise. So this is a rotation of counterclockwise of 90 degrees. Notice that it's the exact same as a rotation of 270 degrees clockwise. So those two things will have the same mapping. So if I start with my point A once again, and A is at -5, 7, then if I want to go to my A prime, we can go back and see what we did. Well, in this case, my A prime is going to be at -7, -5. So going back to my x's and y's, if we start with A is just at x, y, then A prime is going to be at, well, I take my y, make it negative, that becomes x, and my x just stays the same. So that's going to be -yx, which is the same thing that we did for a clockwise rotation of 270 degrees. Now this one is a rotation of 270 degrees counterclockwise, which is the same as a rotation of 90 degrees clockwise. So again, I'm going to start with A is at -5, 7. A prime is going to be at 7, 5. So let's look at what we did. If we started with A is at xy, then A prime is going to be, well, I make my x negative, and that becomes y. So this is going to be -x, and my y just becomes my x. So that's going to be y -x. Notice that I didn't do 180 degrees, and that's because 180 degrees is the same whether it's clockwise or counterclockwise. So here's the summary for the counterclockwise rotation. And again, it doesn't matter where you start, you map them the same way. The last thing I want to talk about is 360 degrees of rotation. In other words, if you go all the way around. We didn't talk about that because if you go 360 degrees, you end up exactly where you started. So it's really not that interesting when it comes to rotation 360 degrees. Okay, here's the summary again, and you're probably going to want to copy this down in your notes someplace. It's the same for all of them. You can always come back to this and do this. All of the rotation that we'll be doing is going to be around the origin, so that's basically what you need. Okay, now we're going to go over a question from your homework. This is Unit 1, homework number 3, rotation. And this is question number 1. It says, rotate the polygon 90 degrees counterclockwise about the origin. So the first thing we're going to want to do is we're going to want to say, which way is counterclockwise? Just so I have an idea of where we're going to be. So in this case, if we started up here, counterclockwise means we're going to go in this direction. Because I'm going 90 degrees, I should end up in quadrant 3 when I'm done. So the first thing I'm going to do is I'm going to find all the coordinates of the vertices of this triangle. So I'm going to find the coordinates of this point right here. That's going to be -4, 6, and then I'm going to find the coordinates of this one. That's -2, 2, and then I'm going to find the coordinates of this one. That is going to be -4 and 2. So what I'm going to do now is I'm going to come over here and I'm going to write those down. So -4, 6, -4, 2, and -2, 2. Since I'm doing 90 degrees counterclockwise, that means if we start with x, y, I'm going to have to go ahead and turn that into -y, x. So in this case here, what I'm doing is I'm taking my x value and making it my y value. So I'm going to start off by taking my x value and making it my y value. Then I'm going to take my y value, make it negative, and that will give me my x. So again, I'm going to take my x value and make that my y. Take my y, make it negative, and my x. Same thing, take my x value and make it my y. Then take my y value, make it negative, and make it my x. So now I need to plot those points. So to plot those points, I have -6, -4. So -6, -4 will put me right there. Then I have -2, -4 will put me right there. Then I have -2, -2 will put me there, and I finish off my triangle, and when I submit that, I got it right. So that's how you do a rotation of 90 degrees.